Well, welcome back. Looks like most everyone stuck around, so that's good. We're going to go ahead and kick off the next session, focused mostly on nutrients. But as you can see, just during his talk, there's a little overlap of things that go on out there. So this will be a nice way to kind of build right into that. So we have Dr. Ellen Paparozzi from on campus. She's an agronomy professor, and I actually took a class with her as well.
That's why I'm here.
That's why right? Like, oh, I know someone that can.
So you talk about boy, can she talk? Yeah.
Right. So anyway, thanks for coming. I'll go ahead and turn the floor over to you, and we'll kick it off. So thank you.
Thanks, Tyler. Am I good? Okay. What I'm going to talk about is, I'm not going to talk about all 14 nutrients. You know there are 14, right? Okay. Some people don't, because nickel was recently added, and it has a limited role, but an important role. It's not something you need to worry about. I'm not going to talk about a lot of the minor elements that we don't have problems with. If we have problems with boron, it's toxicity. I'm not going to talk about copper, because you get it when you put it through your pipes, right? A lot of copper pipes. Molybdenum, I'm not going to talk about. Chlorine, I'm not going to talk about, that kind of thing. I'm just going to try to focus on the 6 macros and a few of the micros that are more of a problem. And I'm going to show you a lot of pictures. And then what we're going to do is we're going to do some case studies, just like in class, where you figure out what's wrong with the plants. Okay, you become your own extension agent. Okay, so nitrogen. This is the one nutrient that when you add it to a plant in both monocots and dicots, the more you add, the more it grows. Okay, and that increases yield, et cetera, et cetera. It doesn't seem to plateau off the way all the other elements do. Okay, and that's because it's involved in so many metabolic processes that, and on the left there, you can see some mature corn leaves with this yellowing. And being a monocot, you have your veins that are linear versus your soybeans, which are dicot, which are palmate. And so in the case of nitrogen, it ignores the veins, and you're going to get yellowing, like on the left, and usually starting on the tips, as well as streaking, which again overlaps with some of the diseases, and it appears all over the plant. Usually starts in the bottom. Macro elements start in the bottom, okay? And this one will progress all the way to the top. And so we see some initial, and then we see something a little later. It can also, in seedlings, and this is not on our soils, but that's sorghum over there. Any sorghum growers here? Yeah, okay. Very similar, get it very early on. Then if it's in a part of the field where you don't get to it right away, as you can see in this photo on the right, and it's on the left one there, you start getting little brown patches, okay? And it will progress. Sometimes it'll skip the yellowing phase altogether. And again, that's because nitrogen is in everything. It's proteins, it's amino acids, it's photosynthesis, it's respiration. It's all over the place. It's in secondary pathways. And so it doesn't necessarily, and when you look at this, if you're not experienced like you all are, you could probably say rust. This is what it looks like in a field, okay? And this was sugar beets. I don't think I have any sugar beet growers here, do I? Okay. But nonetheless, in that dicot, you get this sort of overall yellowing cast. And a field like wheat, like this, you see it follows the pattern that Kyle talks about. Nutrient diseases have patterns, okay? They usually aren't spots in the field, but there are always exceptions. Okay, when we do these kind of things in experiments, and a lot of this work was done by Dr. Ralph Clark and Dr. Jerry Moranville, colleagues of mine over time, You can see at the top left corner there, just some overall looking at wheat in containers, and you get that yellowing. I also threw in some plants in case there are any vegetable growers here. You see it in strawberries, okay, left to right on the top right there. Same thing with lettuce, and same thing with tomatoes, just overall. What causes this? And I'm going to highlight every nutrient that gives a yellow symptomology. You're going to see this nasty yellow thing, just to make a point. What causes it? Cold, very wet soils, similar environments to disease. It is probably the one that we see most often in non-leguminous crops, so that's the majority of crops. It's highly mobile. Okay, so you can get a deficiency when you go to tassel, and you'll start seeing the lower leaves start to die. There's not enough nitrogen there, and the roots can't take it up. They'll take it from the other leaves. It's required in the highest concentration. As I said, there's a linear response. And pH doesn't seem to be affected by the soil pH. Phosphorus. How many of you have seen any phosphorus in your fields? Anybody? Yeah? When do you see it? Early on. Cold, wet again. But it's not yellow. It's usually purple. Sometimes the purple is hard to see, like the far left one. It just appears in one of the top whorls. And that's actually not the top of the plant. Those are older leaves. And here we have it in a very sandy soil, and it's progressed quite far up. Okay, there's no micronutrient that really gives a purpling at the top. Okay, sorghum. There it is again. You see that purpling in the culm, and very important there. And again, on the right here, Dr. Ralph Clark's research that showed that from young to old, it progresses, and it tends to follow along the veins to start out with, and then you could just get this overall purpling. This is P deficiency, but that was caused by damage to corn roots. Okay, so it doesn't have to be lack of phosphorus in the soil. So you get your soil test back and you say, but they didn't say there's anything wrong with phosphorus. This happened to be herbicide injury. And we all know that if herbicide injury occurs early on in the season, it's something to do with the temperature and the soil structure. Okay, and so it was the roots here. And of course, phosphorus is the metabolic driver of all our processes. So you'll find it most pronounced on young plants, and we've seen older plants will actually grow out of the problem. So if you see it and the temperature and the weather get better, it might disappear and things might be fine. Cold, wet, very wet or very dry soils, and very often it is mistaken for other stresses such as insect, temperature, or herbicide. Okay, it's a secondary effect that you're seeing. Okay. Potassium. Potassium, this is a tough one because potassium is highly mobile. It's involved in water relations in the plant. And very often when there are stress symptoms, you'll see potassium deficiency, and it's actually stress due to lack of moisture or irregular moisture application. And it starts in the lower part of the plant. It can be yellowish. It can be brown, okay? Because when the plant is moving water, it moves not just by diffusion, it also is being pumped and brought through by evapotranspiration. And so things can go into those cells very quickly. If a plant is dry, the water can move in very, very quickly and lyse some of those cells. They can break, and then they're going to look brown. When you see a brown patch, it's a dead cell. Okay. Again, here we got yellowing again. Usually some yellow and necrosis on the leaf margins, small chlorotic spots sometimes. can be scattered on the older leaves. Again, it will be on the older leaves first. And if you're growing soybeans, that may be a little hard to see because they're small and bushy. But we'll take a look at that. And the internodes are shorter. The plants are susceptible to diseases. And drought or irregular irrigation is what causes those potassium symptoms. Here we see it on corn, okay? And those are the lower leaves on the left there. And again, there's a pattern. You see this repeated yellowing on the same stage of leaves, okay? This is a picture from one that was done in the greenhouse, and constant potassium deficiency, and the purpling will just move up the stem. This is in sorghum, and in this case, with the sorghum, you see the browning, but you also see the yellowing, and it looks sort of intervanal. Okay, it looks like the green veins are still holding out. Corn, again here, it varies, and again, it varies because we're talking water uptake, and not each leaf in the plant gets the same amount of water at the same time. Magnesium. Okay, so we're doing yellow again. This is another one that's yellow. Again, I gave Kyle the symptoms that symptom sheet earlier on because they overlap. And magnesium, again, it's a macro element. Nitrogen, phosphorus, sulfur, calcium, potassium, magnesium are all the big ones. They are required in the largest amount. You're going to see their response first, okay, if there's a problem. And again, it's on the lower leaves. It's going to be intervanal, which is what separates it from all the other macros. It's always intervanal, and it's usually yellowish, okay? Sometimes there is some purpling, and people say, how come that is? Well, because magnesium is the center of the chlorophyll molecule. If you have no magnesium, you have no chlorophyll, you have no photosynthesis. And so what you're seeing is the lack of photosynthesis, okay, with no chlorophyll. And when you don't have photosynthesis and you don't have chlorophyll, you get yellow, okay? The pigments left in the leaves are yellow, orange, and purple, okay, once you kill off chlorophyll. Okay, so immediately you see the revealing of those other pigments when you lose the green pigment. Okay, the tips and the edges may turn brown and die. Find it on acid or sandy soils. We don't have any acid soils here, but we do have sandy soils in western edge of the state with high rainfall. And for agronomic crops, sometimes because of the position and the way the monocots grow, it's hard to distinguish it from other nutrients. So I always suggest if you think it's magnesium, you should tissue test. We don't see a lot of magnesium, and I don't think has anybody seen magnesium here? You have seen it. What part of the state? Oh, okay. Yes. Okay, we've got those sandy soils. You'll see a lot of these that you won't see down here. But you got a tissue test to be absolutely sure. And we'll talk briefly about tissue testing. So what does it look like? Very intervanal. Okay, as I said, nice white and yellow stripes. Okay, if as a plantologist, I also work with horticulture crops, and we love variegated plants. Not your preferred kind of plant is a variegated plant. You'll start to see brown spots. Again, these cells are lysed and they die. Okay, a good look at what it typically looks like on corn. And here we've got sorghum. Sorghum always has to be just that little bit different. And so it tends to go a little more brown in the center than the veins. The leaves are just that little bit different. Calcium. Now, notice that this is not yellow. Okay. Calcium is immobile, and you will see severe stunting. That's because calcium is the glue that holds cell walls together, calcium pectate. And so any place that is growing, if it doesn't have calcium, the cells fall apart. And if the cells fall apart, they turn brown. And so it's calcium pectate is the glue, and it's also involved in the cell wall fibril laying out with boron. Okay, that's boron's big deal. So boron and calcium have similar symptoms. The tips look like they stick together. We rarely see it in legumes, and that's probably due to nodulation. And if you have fruit, if you were growing fruit of any kind, the fruit would lose its rigidity. This is calcium deficiency again, and this is a sandier type of soil, and the growth is sticky. It also gives this very interesting view on corn if it happens later. We don't have that problem. We've got too much calcium, if that at all. Sulfur. This is the nutrient I worked a lot with for about 10 years because we didn't know a lot about it. And it can be a problem, and its symptoms look similar to nitrogen. And it is a key nutrient for nitrogen metabolism. You don't get nitrate to nitrite to ammonium into the amino acid pathway, nitrate assimilation, without sulfur. Okay, so that's why it's almost like a sulfur-induced nitrogen deficiency, and we have that we see. Legumes and vegetables have a higher requirement than small grains. They're cold, wet soils, which are acid or sandy with high organic matter content. It can be a problem. It's a nonlinear response like most of the others. That means that you get to a point where a little bit is good and maybe a little more is better, and then it plateaus. Adding more sulfur doesn't help. Okay. What does it look like? This is sulfur deficiency in corn, and it can be deceiving because at first it looks a little bit like magnesium, or it can look like nitrogen, except it tends to start in the top of the plant rather than from the bottom. So it can look similar because they're linked. But a little sulfur takes care of this. Okay, view on sorghum and on sugar beets. Again, you've got a pattern here which tells you that something's going on in the soils there. Okay, that on the right there with the sugar beets, part of that field is supplying more sulfur than the other part due to something in the soil structure or whatever they've been doing with it. I just thought I'd throw tobacco in here because it shows the whole plant just starts going yellow. Iron. Okay, and I'm only going to do another one because I can go on all these deficiency symptoms, but they don't mean anything unless you do something with them. Iron deficiency. Okay, this is a problem for us. How many of you have had iron deficiency in your corn or in your other areas? Okay, most of you are good, but again, we've got those sandy soils, which they don't cut you any slack. They don't cut you any slack. With iron, the best thing you can do in our soils. What's your soil pHs? Are they in the 5s or are they? In the 5s, you can actually apply iron to the soil because it's available. And the soils down here where it's 7 and higher, no, it won't be. Yeah, well, no, that's because of some of the fertilizers you're putting on, and we've got more clay and more organic matter, and so that really helps. The only way to really correct this with in a high pH soil would be a chelate that is expensive, you know, and so you have to ask the question: is it worth it? I worked with Dr. Charlie Shapiro and some graduate students looking at alternative methods for iron application with nanoparticles, because they do it in South Africa. The idea is to keep it out of the groundwater. Okay, you don't want iron in your groundwater, right? And we've got to be careful of that. Intervenal chlorosis, younger tissue. Okay, it's at the top. It's in soybeans. Sometimes it comes in as brown necrotic spots. It also affects the root hairs, shortened lateral roots and more root hairs, which is probably why it has a different response in soybeans. What does it look like? This is corn on the left there, and this is soybean. And the corn, it has this. It's definitely right at the top, and it's very whitish, yellowish looking. And soybean, this is very typical, the new growth, and this is a young plant that was worked with, gives a beautiful pattern of intervenal chlorosis. Beautiful if you're a plant nutrition person. In the field, again, you'll see a pattern, okay? There's these dark green leaves in the soybeans, and then up towards the top, suddenly you're getting white and yellow, okay? So it's not usually sporadic, it's in whole areas. I just threw some grapes in there in case some of you are thinking about a crop that you might want to grow, and it looks just as white as anybody else. Potato for the western edge of the state, and that's just chrysanthemum, which is something else I deal with. We do get it in turf and in various places, and this is in sorghum, and I put this in for a good reason. Does anybody know why I put this picture in versus all the other fields? Very dark green and then very yellow with sorghum, with iron. Okay. Looks like it's very wet. Yes, the wet is the key. There's actually enough iron in that soil and around it, but the place where it's wet, it's cold and wet, and so the iron's not available. Okay. So how do you change something like that? Well, not this season. Okay. All right. You have other ways to do it, but you obviously have to do something about the soil there. Okay. It's a low spot, and either you plant something that's not going to show iron chlorosis as much in there, because there are soybeans that, for example, that will not show chlorosis as much. But so sometimes it's not the soils, it's not the temperature, it's the moisture. Manganese. I mentioned manganese because it works in conjunction with iron. Spindly growth, leaf necrosis near the center, sometimes gray or tan spots. But again, it gives this yellow symptom. You're getting the idea of all these nutrients that all could be yellow, all of which can be confused. And here we got a corn, looks something like iron. Chrysanthemum. In chrysanthemum, I only put it up there because in 10 years, I don't know what you guys are going to be growing. Okay, I doubt you'll be growing fields of chrysanthemum, but manganese does display differently in different crops. And in this case, we get some yellowing kind of all the way up the stem, and there's little brown spots there. So just in case you're growing something else. Sorghum, you can see on the far left there, and then the one with closest to the potato and the soybean, that you start getting this blackening. This is work of Dr. Ralph Clark again. And soybean, you get this darkening, actually, of the veins, as well as the lightening in between the veins. Potato, which of course being the way it grows, it gives a different response. You see it at the top and not as much at the bottom, and it's deformed leaves. Zinc. And zinc will be the last microelement I talk about, because iron, manganese, and zinc we're finding all work together. Okay, it's not a single element effect. And so, again, we have tissue tests. Leaves very small, sometimes missing entire blades. You get, again, interveinal chlorosis at the top. Stems and petioles may become reddish. Internodes short, giving a rosette appearance. And so this is rare in the small grains, but we've seen it in corn, other places. Leaves near the whorl, okay, right at the top of the whorl, and obviously these are younger plants. They start looking white. If you get zinc deficiency later in the growing season and you can't see it, what you'll see is it will delay the maturity of the crop. Okay, okay, it has a subtle deficiency later on. That's in corn, and there we have it in sorghum. Okay, I'm not going to bore you with the other nutrients that we've got. I hope so.
Sat through a couple hours of Ag PhD with the Hefty brothers, and they're really stressing looking more at boron. What's your thoughts? You mentioned it in relation to calcium. Can you repeat the question?
I will repeat the question. There's a stress out there about looking at boron. Okay, in terms of application, I presume. I guess I would look at my soil test. Okay, and this part of the state, the southeastern part of the state, if anything, we have boron in the water, and that's because of the structure of the limestone. Okay, and if anything, boron can be toxic to plants.
And a non-irrigation dry land.
If you have a boron problem, it's easy, really, relatively easy to rectify. Boric acid. You can side dress it with boric acid. Okay, and what it will look like is what I showed you for the calcium, because it's those cell walls, and it will be in the young growth. It will not be elsewhere. Okay, so you will catch it early on. Okay, and again, you know, wherever you soil test with Ward, Midwest, AgriSource, whatever, you should talk to them and make sure that the boron is right. I'm not in favor of putting on boron preventatively, like I said, because it too moves through it can move through the soil. I'd be afraid of getting it in there. But we've had a situation southeast of Lincoln. Well, it's still in Lancaster County, where the water had so much boron, you can't grow plants there. Okay, it's toxic. Okay, and by plants I meant ornamentals. You know, people are having trouble growing things on their yards. So, why are they pushing boron?
Yield determination in the early stages of corn.
And have you seen a problem with yield?
Wasn't aware of it till.
So I don't know. I don't think I have a problem, but maybe I think I have a problem.
Well, I've seen symptoms, but I haven't.
Well, boron deficiency symptoms early on is the stickiness. Later on, it would be in the fill of the grain.
And in some of our trials, we've seen yield response with boron going out with that foliar fungicide. And that's the idea, as a sugar mover and increasing seed weight.
Yes, yes.
And a boron moly product is what's generally accepted in industry.
Yeah.
There's a fair database. It's not a huge response, but there's return on investment.
If there's return on investment, then it's worth it. Okay, but I wouldn't be out there correcting for a deficiency that doesn't happen. Okay, your crops are not deficient in boron. You've just decided to accelerate.
That's correct. Yeah.
Right, in yield, and you know depending on your finances, that's if you can do that, and if it has a double benefit, like you talked it as a fungicide, and yes.
I said tank mixing with.
Oh, you tank mix it, yeah. And so if you're going through and making the application, spending the money to do that application, the molybdate, the boron molybdate combination, that could be worth it. Okay. I don't know. It depends what you think is an important yield increase. 10%, 20%.
Well, 3-to-1 return on investment.
Okay, there we go.
If I put out $5.
Plus you get the fungicide protection.
If I put $5 worth of micronutrient and I get $50 worth of grain, that's a good return, even if it's only 4 bushel.
Right. Okay. All right.
The way we do it.
That to me makes sense. But in terms of deficiencies or applications onto before, I don't see it. So.
Except their new researches in Seward County, and that's where they were talking about.
Okay, so if there are boron deficient soils, if there are any micronutrient deficient soils, then you're going to want to follow the soil test guidelines and make that amendment, no doubt. And if you can make it economically feasible, that's fine. So it was just a boron molybdate combination. It wasn't other micronutrients in there that they were talking about?
Well, that's the most common one in the market. And actually, a lot of what's on the market now is a zinc manganese boron molybdenum because it fits vegetative stages and reproductive. And that's probably what's mostly out there.
Mm-hmm.
Basically, your custom applicators, they want one product that fits a lot of crops at a lot of timing. We used to do a zinc manganese early and a boron moly
later,
nitrogen later, but that complicates things.
Right.
So for speed and efficiency, that's the most common.
Well, I think it's important that you do things that will make economic sense. Okay. Because I was talking to a friend who's a farmer here, and he said he doesn't understand it. He's getting what it was 1967. He said he's getting the same prices for corn right as he did in 67, but in 67 he could buy a tractor for $7,000, and you can just about buy a nice wheelbarrow for $7,000 nowadays. I mean, really, So as a plant nutrition person, I can say yes, this is a good idea, but we all suffer with the bottom line, okay? And horticulture crops, which I deal with, we've got control of the bottom line, right? You guys don't have control of that bottom line. And so you've got to be careful where you spend your money. And going through the field once, or running it through the pivot, or not at all, that's the way it's got to be determined, no doubt. But I'm a fan of, how many of you do both tissue test and soil test every year? Okay, how many of you soil test every year? Well, at least that's a good one. Okay. We tend to not tissue test unless we have a problem, and that's fine. But you also need to tissue test if you do something economic, and you want to see if it's effective. And you would want to test before you apply your fungicide with your boron, et cetera, and afterwards, just to see if it's really worth the money. But I would highly recommend that. And sometimes tissue testing is the only way to figure things out. And I'm sensitive about boron because a lot of what we're talking about now in the nutrient circles is balances, okay? And so when you have any of those elements on the left in excess, you may get a deficiency symptom with one of the elements on the right. And so, you know, you've got the nitrogen potassium balance, and it basically it's cations versus anions. Okay. And iron and manganese were the first ones known, but an interesting one is phosphorus. Okay. We also see kind of the reverse there. If we have zinc deficiency, we've just finished some work with zinc and iron and manganese deficiency, we get increases in phosphorus uptake. Okay. And so starting to think about things more holistically when you look at a tissue test is very, very important. Okay. I've had tissue tests back, okay, on greenhouse crops that I've looked at. And one of the responses was, okay, you're lacking copper. They looked at the tissue test, you're lacking copper. And so the grower called me because copper is expensive, copper EDTA. I looked at the tissue test and I said, no, that's not what you need. I said, you need to drop the pH of your mix. And so there's a fertilizer that we use called 2177, which has a capacity, a calcium carbonate capacity of over 1,000 for neutralization. And the higher that total potential acidity is, that means the more power it has to drop the pH of your mix. And so he started alternating with the 2177, problem went away. Okay, so you have to be careful when you're looking at some of these soil and tissue tests, because just because it's in the soil doesn't mean that it's there. We don't have a lot of apps. There's a Yara Check It app that's really about vegetables, but the International Plant Nutrition Institute has a website. They have some nice pictures there and some nice information that you might want to look at if you think you have a problem. So I'll take questions, but otherwise we're going to hand out some case studies and let you be the professor. Okay, Tyler, would you help? Yeah, each guy's going either way. As Kyle said, yes.
In your tissue testing,
Yes.
when you start and doing it weekly throughout the growing season is economically advisable?
Oh, I wouldn't think weekly is economically advisable at all. What I would look at, if I were working with a farmer, a grower, a producer, I'd say, what's your history? You know, what do you think you've had problems with? And depending on what area you think you're having problems with, that's how often you would tissue test. Because if you're having trouble with grain fill, well, you're going to tissue test maybe at like V7 or something like that. If you're having trouble early on with spotty seedling growth and things like that, then you might test earlier in the season. Okay, it depends. What are you growing? Corn and beans? Corn and beans.
I was thinking we were looking at how our fertilizer program was performing.
Yeah.
We were getting enough nitrogen on whatever particular growth stage in our corn that's necessary. On in the fall soil testing, it's carrying through into the spring and throughout the growing season. Whether we change that, how we need to modify that.
Well, a tissue test would be good relatively early in the season then to follow fall application and see what you've got. Okay, and then as you go through the season, a mid-season test, okay, and then a test at the end, and that's tough, you know, testing, because it depends the tissue that you sample, right? Okay, because if you test at the end of the season, all the nutrients are going to grain fill, okay, and taking some nutrients from the lower leaves, okay. So what do you sample at that point? Okay, but it does give you an indication if you do the upper leaves, what the balances are, at least for the elements at the end of the season. So ballparking, it would be, to me, it would be a majority of 3 times. And I'd match that with soil tests because they pair well.
How fresh does a leaf sample need to be before you do analyze it? What's the best way to get them to you quickly?
Well, I don't do any tissue testing, but so you'd have to send it to one of the labs, and they dry them, and they grind them, and they run them either through Keldol or Dumas for nitrogen, and well, actually Dumas is for soil. They run through Keldol or microkeldol, or there's a combustion way, and then they run it through ICAP, inductively coupled argon plasma emission spectroscopy. And so we dry them, grind them, and I send them as little vials or little baby food jars because they're cheaper. And that's how I send my samples in. And I try to give them some background. What is it? What stage is it? That kind of thing. Yes? Yeah.
And they want, up until you've got the smallest college leaf, they like it with 48 hours.
Really?
They'd like it to be cool. Not cool. Leaf tissue breaks down enough to have a hard time getting a sample out of it.
Really? I'm sorry, I didn't know that. I work with AgriSource, and sometimes I work with Ray also, and all our samples have been ground and dried.
Well, they might there.
Yeah.
Just want you to bring a leaf.
Mm-hmm.
Leaf in and they-
Well, and some of that may be because we have special drying ovens, okay? Brown paper bags. Well, that I always suggest you send it in a clean brown paper bag rather than a plastic bag, because like with Kyle's samples, if there's moisture, other things can happen, and in terms of that. So, well, Midwest does a good job. So, what we do at the university, I guess, is a little different. We used to have our own analysis lab, but that went the way of the budget cuts a number of decades ago. So, okay, let's. Can we pull up the?
Yeah, I can pull up on there.
Yep. Let's pull up this case. Okay, the variable growth of corn. This is a case that came to me and my colleagues from Dr. Roger Elmore. Some of you may have known him. And we rely on people to bring us pieces, and we put together the cases. And these are the cases we give to our graduate students because nothing is ever straightforward. Okay, so what's wrong with the plants? They're stunted. That's a good question. Yeah, these are questions to consider. Yeah, it looks like nitrogen, doesn't it? And how do you know there's a problem with the nitrogen? Right, right. Hey, for once it paid to have a soil test, right? Sometimes you wonder, because it looks the same as last year and things like that. Okay. But he put down a starter fertilizer, right? 10-34-0. And they were planted in, right? What did you just say? Yes, look at that. He put a lot of fertilizer down. So how come he's getting nitrogen deficiency? Okay, so you're saying nitrogen is being tied up? How's it being tied up?
Residue?
Yes, the residue. Exactly. And that's what gives it the pattern, right? Okay. And what's that residue from? Our beloved corn from the year before, right? That's corn residue. Okay, so you see the chlorosis, you see the pattern, you see the residue. Okay, so is the herbicide involved with this? You think there's a herbicide problem? Okay, it's nitrogen deficiency, but he put a lot of fertilizer down. The herbicide involved?
I think cooler soil early on.
Right, below 50 degrees. That cool soil. Maybe there's a problem there with the nitrogen uptake. Also, there was some rain, right? Here's that weather thing that Kyle talked about. There was some rain there, so it keeps that soil temperature cool. Yes?
I happen to live next.
Oh, gosh. I'll tell Dr. Elmore.
Not mine, but gotta consider the soil type and the way that field lays, the history of the soils that we're looking at around swamp, highly erodible soils.
Yes?
And so that comes into play with a lot of the stuff that you're looking at.
Absolutely. Absolutely. Right? And so there's some history going on there. There's some residue. You've got, of course, the weather never cooperates. You're getting all these nice little perfect storms. Okay, so what do? Okay, you can let it go. Okay, it'll catch up. And if it doesn't catch up, yeah, if you're not dry land, you can throw some nitrogen through the irrigation, right? But what do you do about or side dress or something like that, right? But what about the future? How can you prevent this from happening? What? How? Right. And how would we do that practically?
Well, if you're using fertilizer.
Right. Mixing it in, that's it. This was a no-till field, yes? Okay. So you'd have to recommend tillage. Okay, if you were the extension person, you'd say tillage. And if the person said, no, I don't want to do tillage, okay, then what would it be? Well, index your fertilizer to your row, that might help. But we've got that residue issue. Rotate, yeah. Go to a corn, soy, okay, or corn, soy, corn at some point. Okay, so you have to rotate. You have to, if you don't want to till and you've got this problem, okay, and then, you have choices. Yeah, but that was before then. Yes, that residue is corn.
Change the fertilizer program.
Ah,
Put half of it on, maybe with anhydrous ammonia, narrowing up your knife spacing. And highest we should 30-inch spacing, 15, 20s, or something like that. It's very high clay content soil, so it doesn't seal well, won't hold a lot of nitrogen.
right.
As well as maybe putting on nitrogen through pivot or dribbling it on.
Right.
Or dry product that has high release.
Yes, the idea is knifing through that soil, breaking up that residue, okay, and with the ammonia, that would help, okay, a lot. But again, that soil's just sitting there nice and shiny, right? So all those suggestions work, okay? All those suggestions work. Of course, our students don't give all those suggestions because they do talk about tractors, but you guys knows best. But good, that's a great one. Next one. Let's give you another one. The next one is going to be soybeans. And then we'll do one more, if you guys want to do one more. I hope you did you find this fun? The students don't find it fun, they find it confusing. I thought this was a plant nutrition course. Well, why do we have to worry about the weather and the rainfall? And there's like, come on, guys. Oh, All right, so this is a case that came to Dan Walters, Dr. Dan Walters, one of my favorite people in the world, and we worked together for a long time. And basically, the question is, we've got yellowing on rows and patterns, and we've got some problems with chlorotic soybeans. Okay, keep going. Yeah, there we go. And go to the tissue analysis. Yep. There we go. Thank you. So, is Raptor to blame for this yellow? You know, who do I sue?
If Raptor did it, the veins would be red.
Okay, if Raptor did it, the veins may be red, right? But what else do you know from looking at the soil and the tissue test? Yeah, stop there. That's great. That tells you that Raptor didn't do that. It could be where the water was collecting in the field. From another field, right? Right? It could be. That could be. What else? What else do we know? Take a look at that tissue test. If you look at the tissue test and the yellowing symptoms, yeah, it doesn't. It's too faint. Take a look at the iron and the manganese. Here. So if you're just looking at that tissue test, which the students would do, this is a plant nutrition course. What does that tissue test tell you? What do you see?
Difference in the iron.
Yeah, a difference in the iron. Yeah, the chlorotic one has high iron, and the chlorotic one has high manganese, and it's giving classic micronutrient deficiency symptoms. Okay, how does that work? Anybody? No? Well, we've already decided Raptor is not to blame, but what's causing the yellowing?
What about the soil compaction?
Yes, soil compaction could be very much be part of it. But what about the soil test too? Let's come down. Take a look at the soil test. And what do we know about the soils in Lipton, Geller, and Boer? All right. Well, we look at calcium. Look at the calcium in there. Calcium is huge, as we would expect. Okay. So you say, okay, calcium is huge, so we know that that affects iron uptake. How come we have so much iron? Anybody? Well, it's what we call Lyme-induced chlorosis. And what happens is the plant takes up the iron, but it stores it in the apoplasm, cell walls. And so it's not available to the plant for metabolism. And so it looks like there's plenty of iron and plenty of manganese, but it's not being utilized in the plant. And we see Lyme-induced chlorosis in soybeans in Nebraska. Okay, it's part of the problem is some soil compaction. There's no doubt about that. But there's high alkalinity in this soil, You could stay where the soil is. Thank you. There's high alkalinity in this soil, which means that you've got a situation where you have high carbon dioxide present, and when it combines with calcium carbonate, it produces bicarbonates. When it produces bicarbonates, that increases the alkalinity. Okay, and so what they call it is Lyme-induced chlorosis. So putting iron on these plants would not help. Yes.
I don't know about these soils up here in North and South Dakota, but is this a case where they soil tested the soil, maybe didn't take a small enough grit sample and decided they needed lime on the whole farm and put on tons to change the pH back?
It's possible that it's possible that they limed before they planted, thinking they needed it, but there's too much lime there in those soils. That soil test is too high for lime. And the plant if you go back up to some of the pictures, please, Tyler. And you can see that the chlorosis is at the top, so that means it's come along later, meaning the plant has taken up some iron. It's taking up iron, but it's not able to process it. Okay, and because you'll see it's a little sporadic, and that's where you've got your. We know that there was some compaction right there. Okay, because you've got low height. Okay, on the plant, and so there's a situation right there. All right, and notice that they also took a field with Roundup, which also had chlorosis. Okay, so part of their fields, that was in Roundup also showed the chlorosis, and so it has to do with the soils. Okay. And this one is, it would be hard to remedy this, okay? With all those bicarbonates in there, it would be hard to remedy this situation. Any other comments on this? This was a tough case for Roger.
On the back page, it shows quite a bit of difference in the nitrogen.
Yes, there's a lot there's a difference in the nitrogen. Let's see could you bring up the tissue test again, please? Yep.
It's on the back. There's a analysis on the back part of right here.
Soil test.
Yeah, there's the soil test. Yes, yes. The nitrogen does vary a lot. There's actually an increase in the nitrogen in the soil compared to the green in the untreated, which is interesting, meaning that they fertilized. And thus the value of soil testing before you put applications on. Other comments about, these are not straightforward, but just to let you know what's out there. Yeah. Yes. Well, all your micronutrients will be unavailable. Yes, yes.
What is there, trying to remember, there's sulfur application, is that it will help lower the pH over time?
Only if you use elemental sulfur. If you use sulfate, it's already oxidized. Any of those 8s are already oxidized. And the problem with elemental sulfur, which is organic, it's slow release, right? You need to put it on in the fall to head it for the spring, right? I mean, that's what we tell our homeowners is, it's winter now, okay? Something to put under the snow. this nice yellow powder if you want to grow your blueberries and your ericaceous plants, et cetera, et cetera. So, yeah, these cases are not contrived, but they're not straightforward. The big deal, I gather, was that they thought it was a herbicide issue. Okay, and we bring it up to the plant nutrition class because they'll all jump at immediately and say, hey, you know, it's an iron deficiency, right? You'll look at it and you say, oh, iron deficiency. But then you find out that the tissue test says, no, it's not an iron deficiency at first blush, but it is actually an iron deficiency. Okay, and so if he wants to correct this, he's got to go in with a chelate spray. And so that turned out to be I think what they did was they let it grow because some parts of the field recovered a little bit. They got low yield, and then they turned it all in. And very, very tragic.
We are out of time.
Okay,
but
sorry.
We can hand those out if you'd like.
Well, if you want another case study, I can give it to you without the answers. But I hope you enjoyed looking at this kind of stuff. This is the kind of stuff that we give to the students. We know that practical experience is not enough for them. Practical experience is the most important part, actually. But we try to give them some exposure to the kind of things that they would see later on. Okay.
Well, thank you. Let's give her a hand.